Some people look at these old radios and see junk, but I see potential. Hi everyone, I'm Jim Hounshell and welcome back to the Old Radio Revival. Before we jump into another fascinating restoration, I want to share a thought with you, something I see played out every single time I work on these beautiful machines. When I bring a new radio into the shop, some people look at it and just see junk. They see the cracked veneer, the frayed wires, the dust, the missing knobs, and they think, that's beyond repair, it's useless. But for me, that's not what I see at all. I look beyond the visible wear and tear, and I see potential. I see the craftsmanship, the history, and the intricate design that, with the right care and attention, can be brought back to life, singing just as beautifully as it did decades ago. And here's the wonderful truth. God sees that in all of us. You might look at yourself and think, I'm too far gone. I've made too many mistakes. I'm too old, too broken, too damaged by life's hardships to be useful to anyone, much less to God. But that's not what your Creator says. In Revelation 21:5, a powerful promise echoes through the ages. Behold, I make all things new. That's not just some things, not just the easy fixes, but all things. He looks past your outward appearance, past your past failures, and sees the incredible potential He designed for you. Just as I see the hidden functionality within a silent radio, God sees the original design and purpose He instilled in you. He doesn't see a pile of junk. He sees a precious creation, marred by sin and time perhaps, but never beyond His restorative power. Obeying the gospel means trusting that God can restore even you. It's laying down your self-doubt, your feelings of worthlessness, and saying, God, I believe that you can take my brokenness, my past, my perceived uselessness, and make me new. It's trusting in His limitless grace and power, understanding that His ability to restore far outweighs any damage life or sin has inflicted. Just as I trust the original engineer's design for these radios, we are called to trust God's perfect design and His power to bring us back to His intended glory. So as we prepare to take these seemingly useless old radios and bring them roaring back to life, I want to encourage you, if you feel old, broken, or think you're too far gone, remember God's promise. He makes all things new. Trust in His restorative power, obey His gospel, and let Him show you the incredible potential He sees in you. Now let's head over to the workbench. Now let's move on to the second coil, which is number 8 on the schematic. If we look at number 8 in the parts list, it shows that that's the oscillator coil. And again, if we look up at our picture, we can see that number 8 is right next to the one we were just working on, the antenna coil. So it is the second one over from the edge. And you notice it's got several more tabs on it. But we will use our schematic and we will figure out where we need to place our probes. So if you look at the schematic, you'll see that first coil, the top part of it is connected to number 7. So if we go to our parts list and we look at number 7, we see that it's a compensating condenser. And if we look it up there at our little drawing, we can see where number 7 is. So we go back to our chassis, we find out that this is number 7 right here. And the top part of that coil is connected to it. Well, I see 2 wires connected here. One wire, the top wire here, connection, is going to the 36 tube. And that happens to be on pin 2, which is the plate. So if we look at our schematic, we see from part number 7, there is a connection to the plate of the 36. So that's that wire. We want the other wire. So the other wire is on the bottom. And that wire, if you follow it through, it goes over and it connects to this particular tab here on that coil. Okay, so we've got that one. Let's find the other one. If we look at the schematic, the bottom of that coil is connected over to one side of number 12. If we look at our parts list, number 12 is another compensating condenser. So if we look at our drawing, find out where number 12 is, we go back to our chassis, and we find that this is number 12 over here. And there's one wire that connects to it. If you follow it back around, you'll find that it connects to this tab of the coil. So these are the two places that we want to put our probes to see if we have continuity. And we do. Excellent. So now let's take a look at the other coil. Go back to the schematic and we notice that the top part of that coil is connected to the tuning condenser. Remember on top we saw the tuning condenser. If we take a look here at the wires coming off of this, we find one that goes to the top of the chassis through a hole here. It's hard for you to see, but it goes through a hole to the top of the chassis. And if we look on top of the chassis, we see that it connects to the tuning condenser. So then we look at the schematic and we notice that the bottom side of that coil is connected to the bottom side of the other coil and to that same part number 12 there. So if we take our probes and if we remember, this one was the bottom of the other coil, and this one is the top of this coil, and we have continuity. So now let's check the next set of coils. On this next coil, we see that the top part of it connects over here to the 36 tube, to the plate. So one probe will go on the plate of the 36 tube, and this particular 36 tube is the detector oscillator tube. And the bottom end of that coil, if we follow it all the way over to the 42 tube, we see that it connects at what's called the screen grid. So we will place one probe on the plate of the detector oscillator, which is pin number 2, and the screen grid of the 42 tube, which is pin number 3. So we look at our tube, we know this one's our 36 tube. We go to the plate, which is pin 2, put our probe onto pin 2, and this is the 42 tube up here. And we want to put our other probe on pin 3, and we have continuity. Excellent. So now if we go back to our schematic, we look at the second coil of wire there. We see that one side of it is connected to this part 17, which we looked at our parts list here, and we found that that was a compensating condenser. And we see that the other end of the coil then is connected to a part 18, which if we look at our parts list, we see that that too is a compensating condenser, and on the diagram, its location is here. By the way, this set of coils that we're working on now is in the IF can, and it's this particular can over here. We can tell that from the first coil that we did. If you follow those wires back, you'll find out that they go to this can here. Now, in this second set of coils, we see that the 17 had a connection to the can, and we want to connect the other probe then to the 18, but it's got two wires on it. One wire goes to the 36 tube. Well, if we look at our schematic, we see on the 18, one wire does go to the 36 tube. It goes to the plate. That's not the wire we want. We want the other wire that's connected to number 18. So that'll be the bottom wire down here. So we'll connect our probes to those 2 points, the bottom of 18, top of 17, and we see on the meter that we have continuity. I don't hear a sound on this one, but it's showing low resistance, so that's what we want to see. All right, let's move on to the next set of coils. We look at the schematic and find that they are over here on the left side near the speaker. In fact, if you look at part number 28 there, you'll find that that's the output transformer. The output transformer is on the speaker in the back of the case. You remember we removed the wires from the that came off the speaker and went to the chassis. We will need to put those back on in order to check for continuity. So you remember they were 1, 2, and 3. And so we're just going to connect up some connections here. Put that one on 1, this one on 2, and put this third one then on number 3. All right, got those hooked up. Now let's hook the other ends up to the wires that we disconnected from there. So we've got our yellow cord connected to the number 1 spot, the one we labeled number 1. So we go over here to our number 1 wire, connect it. And we've got red at number 2, connect it to the number 2 wire. And green on number 3 there. So we'll connect it to the number 3 wire. Okay, so we've got our speaker connected back to the radio so that we can check for continuity through the primary and secondary of the output transformer. So if you take a look at the schematic, you'll notice that the top of the primary of the output transformer is on a plate of tube 42. So on the plate of tube 42, here's tube 42, remember? Our plate was pin 2. So we'll place one lead on pin 2, and the other lead, if you look at your schematic, you'll notice that it comes down and connects to another coil. We can check that coil at the same time. If you go up through that coil and down, you'll notice that it is connected to the filament of the 80 rectifier tube. So pin number 1 is the filament that it's connected to. So here's our 80 rectifier tube. And there is pin 1 right down here. Touch that. And you notice that the meter shows that there is continuity through both of those coils that we're checking now. So next we have the secondary. And if you look at the schematic, you'll notice that it is connected both ends to the speaker, to the voice coil. So the way to check that will be to place a lead on both sides of these connections on the speaker here to see if we have continuity. So when we do that, we see that we do. So all of the coils up to this point are good. Now we need to check the transformer. That is the power transformer. And looking at the schematic, we see that the primary, the top side there, is connected to the switch. And you see the switch in the open position, meaning that the radio is turned off. It's in the off position. If it were on, there would be connection there, and you would be able to follow that right out to the top prong of that plug. So we want to turn the radio on so that there will be connection there, and put one probe on the top prong. And then if you'll notice, the bottom of that primary is connected to the bottom prong. So we'll put the probe on both prongs, and we should have continuity there. So let's check it out. We do. So there is continuity there. So looks like our primary might be all right. Now let's take a look at our secondary. The top secondary there is connected to the filament of each of the tubes. So we can take, for example, straight up is the 42 tube. We can take and place one prong on the filament, and our other probe, I should say, on the other filament of the 40 tube, the other side of the filament. So that would be number 1 and 6 of the 42 tube. So let's take a look and see if number 1 and 6 have continuity. And they do. So the secondary, that first secondary winding has continuity. And like I said, that powers the filaments of each of the tubes. The second one down, the next one down of the secondaries is connected to the filament of the 80 rectifier tube. So it powers that filament. So we just need to put a prong on each filament, each side of the filament on the 80 rectifier tube. Let's do that. That would be number 1 and number 2, 3, number 4. And we have continuity there. So if we move on down to the last secondary, this secondary is the secondary that provides the B+ for the tubes. The top of the secondary and the bottom of the secondary are both connected to the diodes within the 80 rectifier tube. So those are the other 2 pins on that tube. We just need to put our probes on the other 2 pins of the 80 tube. So let's see what we've got. And we have continuity there. So the primary and the secondary of our power transformer seems to be okay. That's good. In fact, all of the coils in this radio seem to be all right. That tells me, at least in my process, that it's okay to move forward in replacing some of these resistors and capacitors. So that will be our next move. All right, we're ready to switch out some capacitors here. The first thing I want to do is I want to get rid of this cord. It's just in the way when I'm trying to flip this thing around. So I'm going to cut it on the outside part of the chassis here. We're not going to use this anymore. We'll replace it with a new one. And I've left the inside parts. It's a guide for me to tell where this thing will hook up when I put the new one on. Now, if you have looked under a chassis before, you probably are wondering where these are, because these are paper capacitors and they're usually everywhere under here. But Philco did something different. Philco put their capacitors in these Bakelite blocks. You'll see them here. There's 4 of them under here. These bigger ones hold 2 capacitors. These will hold a single capacitor. So there's 6 capacitors that we're going to change out. Now, there's 2 ways we can do this. We can do it the easy way, which is to cut off one lead. What's going on is there's a paper capacitor inside this block encased in tar-like substance. It may be tar, I don't know, but it's encased in there, and the leads come out these holes. There's 3 holes. They may not use all of them, but there's 3 holes, and they'll put those leads out here to the connecting points. So one way of doing this is you can unsolder that lead
clip it off as close as you can, and then push that lead back down in that hole so that it's not touching the connector. Do that on at least one end. And then hook up your new capacitor on the outside here. So you'd have a capacitor here on the outside, a couple of them here, a couple of them here. That's one way of doing it. And certainly I've had to do it that way on a few of these blocks because they're really tight on some model of radios. They've got a lot of components surrounding them, and it makes it difficult to get under them to get the old stuff out. But these look relatively easy, and we're going to try anyway to pull off this Bakelite block, pull the stuff inside the block out, and put in new capacitors on the inside of the blocks to keep them hidden, you know, like they've got here. That's going to be our attempt anyway. So let's just start with this one. First thing I'm going to do is clean it off a little bit so we can see exactly where those leads are coming out. Just using alcohol and an acid brush here. See if I can clean off the top of this a little bit. Sometimes these things will, I guess, get warm enough to actually leak out some of that tar, and it comes out these holes on the bottom and really gunks it up to where you can't really see what's what. All right, but I think we can now. I believe we can see, and it looks like that looks like the two leads are on the outside posts. So first thing we'll do is unsolder them. What we've got here is a little, I don't know, dental pick maybe. I got these at Harbor Freight, a packet of them, and they kind of help me in situations like this. Once I get this solder loose, which can take a minute. Okay, we broke it loose there. You can see it, I believe. It's loose on that end. Let's work on the other one. It's wrapped around this post, but I can just break it loose like that. You see that tar coming out of there. So scrape that away. All right, so we've got those loose. Now let's get that post off of there. Now there are a few other components connected to these posts here, and I really don't want to have to disconnect all of those to take the block off, empty the contents and so forth, and then put it back on. That's a lot more work than I would really want to do. So I'm going to do my best just to unattach it from the chassis and then flip it over the best I can. We'll see how it works. So we just got one screw here. Take that out. I'm not going to bag it because we'll be putting it back on here before too awful long. And let's see if we can flip it or not. Being careful. Okay, so I think I'm going to be able to get this all out of here without removing anything. So if you take a look there, this is just tar. And so what I've got to do is take a heat gun, get that very hot, get this block hot, so that will let loose and come out of there. And it will have the paper capacitors then either at the bottom of it or still within it. But that's our next step then, is to put some heat onto this thing. But what I want to do is cover up as much of this. I use aluminum foil just to keep all these other components from getting the direct heat of that heat gun, because it is very hot. And we don't want to ruin other components under here. So that's what I'll set up now. All right, so I've got it wrapped up here. Here's our block. I'm going to apply some heat to it. I'll probably turn the sound down once we get started here so you don't have to listen to that. But let's see if we can melt that off. Let's see how we're doing here. We're getting some of it. Don't know if you can see that or not, but that is the capacitor in there. So we're getting a lot of this out of the way. Not sure if it's enough to get it out yet or not. Yes, it is. Here it comes. So there we go. That wasn't as bad as I anticipated. So there we got that capacitor out of there. And what I'll do now is I will just clean this up, get a lot of this tar out of here, and then we'll come back with the new capacitor and I'll show you how we're going to put that in then. All right, we got that cleaned up a little bit. I wanted to show you what came out of that. This is the paper capacitor, and had leads on both ends, went up through them holes. And if we look at our schematic, we'll see that that particular capacitor is number 27, which is a 0.006 microfarads. So the closest I have is a 0.0056, which is pretty close. So that's what we're going to use. This is the new capacitor then that will go in there. Now if you can see in here, you remember the leads came out of both ends. We've got 3 holes there, came out of both ends. So that's the way we're going to put it back in. Just going to bend these leads like this, That should work. We're going to put them in there. Stuff that down in there. Start twisting this back around so we can get them leads. Here's one of the leads. Here's the other one sticking out the hole. Pulling them down tight so that that sits in the bottom nice and snug. Flip this back over. And we'll put this back on. Got our screw. All right, nice and snug. Now here are our two leads coming out both holes. And we will, some of that tar has seeped out of there when we heated it up. So I want to clean that up. Then we'll wrap these leads around those terminals there. Scrape some of that off. All right. Twist this lead around this one. And this one around this end. Actually, we still got a little wire in that. I'm going to clean that up just a little bit. Get my dental tool. There we go. All right, that's better. Got some of that old wire off of there. Let's wrap this one around there. Like that. So now what I'm going to do is I am going to put a little bit of this paste flux on it. This solder has rosin core in it. This flux heats this up really quick and helps that solder melt quicker. And I don't know, I just think it makes a better connection. So I put a little bit, it doesn't take much. I mean, this thing's going to last me a couple of my lifetimes. But just put a little bit on there. If it'll stick. And then let's solder these on here. All right, we've got those on. Got a good connection there. Good connection there. Let's cut off the extra length of these. And there we have it. So there's our first capacitor changed out. Wasn't quite as hard as I thought it would be, but they can be very difficult depending on the model that you're doing. I'm not going to bore you with doing all the rest of them, but I told you I'd do my best to keep these at around 30 minutes long. So let's stop here, and next time we'll replace those capacitors in the last twin block together. I want to talk to you about the line filter capacitor that's in that block and the use of a new safety capacitor as a replacement. Until then, check out the videos in the beginner series. I think you'll like them. I hope you're enjoying these videos, and I hope you'll subscribe. It's as easy as clicking the subscribe button. Well, thanks for watching, and I'll see you in the next one.